So this is Wireshark Wednesdays number 2. I know last week we had a pretty packed house. It was about 60, 70 people. Um, Quite good. Start off a little bit slow, but that's just because we want to get the beginners up to speed. This one, number 2, is going to be kind of the same. We're going to be looking at two routers. We're going to Wireshark it in between two routers inside of GNS. We're going to be looking at things like CDP, ARP. We're going to be looking at KeepLives and MAC addresses. We're also going to see how things look normally. And then in later meetings, we're going to use Kali Linux and other hacking tools, and we're going to send attacks and just to see how things look differently. And I'll explain why we're gonna work it that way. So gonna kill that. Don't need that anymore. And we're aiming for about 70 minutes. And 70 minutes on the dot if someone sees me about to hit 70 minutes. So that would be around what 7:10, 7:15 Pacific time. If I'm still talking, just hit me in the chat window or turn on your mic and say, hey, we're about to hit 70 minutes. And I know because your time is valuable, and we don't want to go for like 2 or 3 hours. And I'm sure on the East Coast, it's 9 o'clock. It'll be hitting 10 o'clock around that time. So you guys need some sleep, right? Goals, we're gonna, as I said, learn how the network functions normally, see how CDP works normally, see how KeepLives work normally. And then later, we're gonna see how things look differently when you're under attack. And it's going to be very helpful for those of you guys who are going for CCIE routing and switching, because there's this new section in there called diagnostics. And in diagnostics, you have to compare how things work normally versus how things work when stuff's broken, right? So if you don't know how CDP or ARP looks normally, how many times ARP requests come through per minute, or let's say that you can't really troubleshoot any problems because you don't have a good baseline. And next sessions, we're going to be looking at routing protocols. I think in the next section, we'll do RIP. We'll look at OSPF, be looking at those packets as they come across. And then the session after that will be Kali Linux. Just as a reminder, next week, if you look on the schedule, we do not have a Wireshark Wednesdays. It's actually going to be in 2 weeks because next week is actually DEF CON, B-Sides, Black Hat, all the good hacker conferences in Las Vegas. So if anyone else will be there, I know Sheldon's going to be there. Sheldon and a couple other guys. We'll see if we can have a little meet up there. And just a disclaimer, same disclaimer as before, this session is being recorded and the opinions expressed here represent my own and not those of my employer. And announcements as always, any certification passes in the last week. Anyone passed a test in the last week? Or did anyone start studying for a test in the last week? Okay. No, nothing there. Any new jobs? Let's see, still studying for CCNP route. Yeah, CCNP route's good. I actually like that one. Okay, good. As long as you are progressing, that's good. Okay, so agenda. We're going to do a quick review of session 1. So we're going to kind of kick over the cobwebs a little bit, go over some filtering, go over some making of a new column. You did that last meeting, but we'll just quickly review it. We'll go over how to set up Wireshark in GNS3, and then the MAC addresses to keep alive CDP and ARP. So fire up Wireshark and open up that baby steps 1 packet trace, baby steps 1. And if you have everything set up, if everything worked correctly in Windows and Linux and Mac, you should be able to just double click on baby steps 1 and it'll open up and packet trace will open up. You don't have to open up Wireshark first and then do the open trace. You just do it in one shot. So I'll give you guys about 30 seconds to have that open. So baby steps 1 from last week. Okay, so from last week, you know that in this pane right here, This was the frame list. Down here, info panel, you can expand these. We learned that in this info panel, it goes from layer 1, layer 2, layer 3, it goes on up, right? As you click on the different frames, the different information is highlighted down here. In the columns right here in the frame list, this is kind of the default right here. You got the number, the time, this is seconds, milliseconds, microseconds, all that good stuff. Source, destination, MAC addresses, the protocol that it recognizes. I've got a couple columns that I made here, and that's because I'm in a different profile. Actually, let's switch here. And we covered last week that if you click on the profile down here, that if you can change to different profile, you could change to the weird colors, classic if you wanted to, right? I kind of like the classic one. We can change the font size, we can zoom in. That's sometimes very helpful. And just like Excel, if you click on the column, the dividers, you can resize them. And that's always very helpful. And down here is a hex ASCII representation of the data inside of the packet, right? It's the whole packet. And if you guys are used to a hex editor, it's very familiar too. Right? So that's all should be very familiar from last week. We spent a little bit of time last week doing the filter box right here. So you can see inside of protocol, we have ARP and CDP. So in the filter box, if you type in CDP and enter, you're going to filter out everything for CDP. If you go back to the filter box and you type in ARP and hit enter, you're going to get all the ARP. If you want to clear it out, you could either clear out the text and hit enter, or you can hit the clear button right here. If you want to filter by a certain MAC address, what you can do is, there's a couple ways you could do it. If you're Uber, you could just go in the filter box and type in ETH, that stands for Ethernet, and I think it's dot, and ADDR, stands for Ethernet address, double equals, and then the MAC address if you wanted to, right? You type out the MAC address. In Wireshark, it's very similar to programming, where it's double equals stands for equals. You have the exclamation mark is the not. So we'll be doing some of those type of filters later on. Okay, so if you want to type it in and filter, that sometimes is a little bit too long. If you want to do it a better way, what you could do is you can click on any of these frames. So just click and highlight any of these frames. Go down here to the info panel, and right here you see Ethernet 2. You see destination and source, right? So under source, find one with source C2001540. And if you right click on that, you can see apply as filter. Apply as filter. Okay, so Abram says, can't see your cursor. So let's try this. See if that helps a little bit better. Okay, so where I have it highlighted, source, then what you're going to do is you're going to right click on that guy, and fifth one down is apply as filter, and then selected. And you're going to see that the source column, now everything for that source is in there. I've got some other stuff too. Okay, it's in the other side. It's fine. So as long as it appears somewhere, it's fine. Got some OSPF in there as well. Now this OSPF is showing up because it came from my side, so it's the same source MAC address. So if you look right here, you could have done the same thing typing it out, eth.source double equals, and that's the MAC address. And then look in this column, everything matches up. So if you know the MAC address, it's very simple to filter things out. Right. Now if you wanted to filter out everything not from that guy, it's pretty easy. Basically the same deal. Just go up here to clear it out, blank it out. You get back all your frames. Then you go down here, back down here to Ethernet 2 source, right there. Expand it out, and let's say if you go down to the second guy, source C2001540, if you right click that guy, apply as filter, notice that under selected you also have not selected. So this means give me everything not matching this. So it's reverse logic. And you could build complicated filters. You could say this and this and this or this, and this is with these different options down here. Right? Once you get really good and you get enough practice with Wireshark, you generally never need to go down here. Once you get really geeky, you learn the syntax and you type it in filter. Okay. So this is very simple review from last week. Nothing too crazy, right? And hopefully you played around during the week, playing around with Wireshark and just doing different types of filters. You know, you see the OSPF here. Oh, how do we filter out just OSPF? Really simple. Just type in OSPF, right? Now, if we want to filter out, as you will save OSPF for later, but you know, for those of you guys studying for CCNP, you know, well, CCNA and CCNP, you know that there's different type of OSPF packets. There's hellos and updates, right? So hellos and updates, if you want to filter just the hellos, it's really simple. Click on one of the OSPF packets, open up OSPF, open up OSPF hello packet, and you should be able to right click on the OSPF hello packet, apply as filter, selected, and you're only going to get OSPF hello packets. Right? You can see that's pretty ugly right there. OSPF hello packets matching that Ethernet source. Okay, so on this one, I would use the GUI on that one instead of typing that out. Okay, so we have a question here. Is there a list of filter syntax or a source where we could look it up? Packet Life has theirs. You can go to the Wireshark University, or you can go to the Wireshark page, and it has a list of filters. It is huge. It is beyond crazy how many filters there are. What you could do, this filter box is very much Cisco-like. So let's say you type in E, just E, and you don't know what, you know it starts with E, but you don't know what happens afterwards. If you look there, it'll bring up a list of everything that comes after, and there's just a whole bunch of stuff that comes up. You know, E donkey, look at that, and then it will fill in stuff for you, and it'll let you know if you have it right or not. So ETH, it's green, so you know it's good. ETH dot, and then you have a whole bunch of crap after that, and it gets pretty crazy. And trust me when I say this, the certification in Wireshark makes you go through all these filters and stuff. So the depth that you study Cisco for in, let's say, CCNP routing and switching, you're going to go down into that detail for Wireshark. And this is just one program. So imagine how crazy you get with Wireshark on that. All right. So close out Wireshark. We're going to do a little GNS3 now. We're going to open it up later in like 3 minutes. So if you want to capture with Wireshark inside of GNS3, it's very simple. And the reason is inside of GNS3, if you install it normally with the all-in-one package, you're going to get Wireshark automatically. You probably remember that there was a pop-up that came up and said, we're going to install Wireshark, right? And hopefully you clicked yes. But if you didn't, it's okay, because if you installed Wireshark afterwards, you can always point it by going to Edit and Preferences. So we're going to have a very simple topology here. We're going to have router 1 and router 2. I'm going to connect it up through the fast Ethernet interface, fast00, using the 3725 image. If you don't have the 3725 image, no big deal. You could pretty much use any image that you have. And then I'll show you how to start up the capture and start up Wireshark. If you watch the video that I sent the link to, that's exactly what we're going to do now. It's very simple. So fire up GNS3. And I'll start from scratch, so we'll be on the same page here, because I already have my topology saved. Okay, fire up GNS3. Just click cancel on that project window. Our first order of business is to go to Edit and Preferences. It's in the upper left-hand corner. Edit and Preferences. And then we're going to go to the Capture option, which is the third one down. What we need to do is we need to tell GNS3 to point to Wireshark, or else it doesn't know where to find it. So we're going to go to Preferences and Capture. Now you have a drop-down list. You have different options here. You're probably going to pick on Wireshark Live Pipe Traffic Capture. It might be the default. And just click on Use. And after you click on that, it's going to fill in the path for you. And hopefully it's the right path. I wish with GNS3 that there was a test button here. And then the working directory for capture files, this is where it's going to dump your capture files. Up to you where to put it. I generally don't like using temp folders, just because, I don't know about you guys, but temp folders is like the black hole. It tends to be a folder that you just dump random crap into, and 3 months later you're going to go back to that temp folder and go, what the hell's in here? So you might want to make a folder called Wireshark dump or Wireshark capture or GNS3 capture, something like that, so it kind of makes sense for you. But for now, let's pretend that you give it some folder. Some people like doing OneDrive or Dropbox for this, and that's fine. Just realize that if you get a big capture, you could go over your limit for OneDrive or Dropbox. And I'm curious, out of the crowd, how many of you use some type of cloud storage? Google Drive, OneDrive, Dropbox, SugarSync. There's probably like 5 others at least out there. Yeah, you should always have an updated copy of your resume on your cloud storage. And always carry a USB stick with your resume on it. Just a tip. Because you never know when that opportunity comes up. Yeah, cover letters are good too. Okay, we'll click OK. So now hopefully your Wireshark is connected to GNS3. We're going to drag in two routers. So click on the routers icon over here in the upper left-hand corner. 3700, and we're going to drag in two of them. So R1 and R2. We're going to click this add a link icon. Click on R1 fast 00. You get that link line. Click over to R2 and fast 00. Pretty much the simplest router configuration you can ever do. All right, two routers. But you'd be surprised, you can do a lot with just two routers. And sometimes it's a good job interview technique. If you're interviewing someone for network engineer, fire up GNS3, bust out with two routers, open up the consoles, turn the laptop around to the candidate and say, okay, well, show me how you configure IP addresses on both sides and do a routing protocol. And just look at how they type. You can tell a lot by how they type. And you can tell if they've been out of work for a little bit. I mean, it kind of sucks, but there should be allowances made if he's been out of work for, let's say, a year or so. You can tell if they're sharp, if they're on the ball. You can tell if they're BSing you quite easily, if they're fudging it. And yeah, as they type, you can ask them things like, why did you pick that address? Or why did you pick that subnet? Why did you pick that autonomous system? Why did you do router OSPF1 instead of router OSPF2? You know, stuff like that. Simple stuff like that, right? So, not really a stress test. I mean, you can make it a stress test. You can, while he's typing, you can bang on the table and scream at him. But, you know, it's just a friendly, just, you know, I don't like to make it a stress test. The guy's stressed already. So just, you know, just configure, pick a protocol. Don't matter. RIP is fine. And just have him explain stuff. Okay. Oh, one other thing. For those of you guys who may have practiced this before, how many of you have actually Wiresharked inside of GNS and you have a lot of crashes? You might have been capturing for like 5 minutes and then just Wireshark bombs out and it gives you that error. I think it's like frame too long or something like that. Has anyone gotten that error before where Wireshark crashes while sniffing inside GNS3? Okay. So if you have no crashes, that's probably good. You probably have a newer version of GNS3 that has the new dynamips. If you have the old dynamips, I forget what version it was, but you can check dynamips version by going up here to File, Edit. So Edit and Preferences. And then the second option here under dynamips. If you go to your dynamips folder, let's see if we click, oh, I don't want to delete. Yeah, don't do it. Don't do it because it's going to delete your topology. But if you didn't have anything running, you test it out. You can go inside your GNS3 folder and check out the version of Dynamips. There's a new one out that fixes the Wireshark crashes. So if it's crashing a lot, you may want to look at a newer version of Dynamips. Okay, but if it's working fine, don't worry about it. Okay, now we're just going to click play. Router 1 and router 2 should fire up. And then click on this console icon just to the left of the green triangle. Console to all devices. And the PuTTY session for both routers should open up. And let me change the font on here so you guys can see. .16 font. Oh yeah. Here we go. So that should be easy to see. Okay, so we have no interfaces with IP addresses. Everything's shut off. I mean, you can verify that by show IP interface brief, right? Administrative down, no problem, right? And if you want, you can resize your windows. Okay, so we verified that everything's down. Now, if you go back to your topology, if you right-click on the link, you're going to get an option Start Capturing. Start Capturing. So click on that. It's going to give you a choice. You're going to have a drop-down R1 or R2. It doesn't matter which one you pick because it's just going to start capturing on this link. You're going to get the same information on this one. So let's just say we pick R1 fast00. We'll click OK. And let me show you something cool. Usually, as you probably notice, I keep my GNS3 screen very clean. I don't have all the panes, the right pane, the left pane, the bottom pane open. I kill them all. And that's because I want space. But if you have all your panes killed, you can go up here to View, and there's different docks, right? If you go to docks and you go to the bottom one, Captures, click on that. And you can see on my right hand side, I've got a dock here for captures, and it's telling me that I am now capturing on R1 side. So why is this important? This is important because if I have multiple links, I can capture at multiple links at the same time. I don't have to capture just on this link. If I had some crazy topology open with 10 routers, like 50 billion links, I can be capturing on all those links at the same time. And you may be wondering, how do I do that? Well, you would see everything listed here, R1, R2, R3, all that good stuff, right? Notice what happens if you right-click on R1 inside of the capture dock. What's that first option you have there? So that first option, yeah, start all captures. So you could fire up 10 captures at once, which is pretty cool. But if you're only running router 1 and router 2, this capture dock is just taking up useless space. Okay, so you started the capture. That's good. Nothing special really happens just yet. So now you just click on Start Wireshark. And with luck, everything's pointed to the right place. Wireshark takes the options from GNS3 and automatically fires up. Right? Nothing too exciting right now because the interfaces are not up. They're just sitting there. Okay, how many of you are at this point? Your routers are on and the Wireshark window came up. No Wireshark.
It's installed. I just couldn't figure out how to get it to start when I started the routers.
Oh, no problem. Did you go to Edit and Preferences and find that link or find the path? So
I'll edit the path and see if that changes it.
yeah, so
It should be exactly where it says
should.
tail.exe is.
Yeah. Well, let's see here. So if you go to Capture, right? Did you click this Use button? So right here. Oh, okay. So what happened? This path doesn't update until you click that guy. I know it's kind of stupid. Yeah.
I take my hat off to whoever programmed this. This is amazing. And the Wireshark is amazing. So, a little bit of fudging, okay.
Yeah. Yeah. Yeah, trust me, I did that too when my first couple times it's yeah, and then oh, you have to actually click on that. Yeah, a similar situation happens when you're trying to pick the PuTTY client. It doesn't actually update until you click on a certain thing. So, okay, so Wireshark is up, and let me just see if I can resize here. So nothing too exciting is happening right now. A little bit boring. So all we have to do is go to router 1. We're going to do something very simple. We're going to turn the interface up. So interface fast 0, no shut. And as soon as you no shut that guy, you can see that Wireshark has some stuff. Right, we've got some information here. All right, we have some frames. It's telling us CDP, VTP, DTP, all that good stuff. Cisco Discovery Protocol, right? And we have this wonderful loop thing, which I think I explained last week. This is the KeepLives. And if you know what's funny is in one of the Cisco Learning Network, they have their forums. I saw a post from a couple years ago. It's like, I keep getting these loopback messages. And for the next couple pages, people were trying to tell this guy, no, it's not a loopback message. This is a KeepLives. But he was just looking at the name here, and he was getting confused. He's like, I didn't set a loopback on this router. I was like, dude, it's not a loopback. It's just, it kind of functions. If you think about the name, I'll explain a little bit later what exactly it does. But it's there pretty much to detect loops. And so that's why you see the loop in there. But it has nothing to do with loopback interfaces. Right. So with one router up, there's no other devices. This is normally what you will see. You'll see every 10 seconds, you'll see the KeepLives fly out. You can see here under the length column that KeepLives is 60 bytes. That's normal. You see CDP, every few, so we have CDP right here at on my screen at 62 seconds, and then at 2 seconds. So it looks like every 60 seconds, except when the interface first comes up, I think all of you should see 3 CDP packets fly out, or 3 CDP frames fly out within the first couple seconds. That's because it boots up and it just goes bang, 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 just shoots it out. All right, so this is very normal what you should see right now. All right, and we can see our MAC address. And notice in these loop frames, the MAC address for the source and the MAC address for the destination is the same. All right. In the data part, if you go down here to the data part and you expand it, it's all zeros, nothing too crazy. You can expand out all these. Source, destination is the same. So it's normal, not a big deal. Okay, so we have a question. I'm stuck at waiting for capture input data. Waiting for capture input data. So it sounds to me that you're probably not capturing anything. So is your Wireshark, if you're seeing a red stop icon right here, it means that it is capturing. So make sure it is capturing. And make sure you're capturing on the right interface. So you should probably go into GNS3, View, Docs, and Captures, and just make sure, let's say R1 or R2 has a green light there. And then you should see stuff come flying in. Okay. All right, this MAC address, it's kind of ugly. I don't like typing this in. So let's change our MAC address. Well, first of all, let's see if we can change it. And if we can change it, let's see what we can change it to. So we got this MAC address here. First, let's go into R1. And if we show interface fast00, you're going to see that that MAC address that you see in Wireshark, right there, so the MAC address that you see right there is the same as the MAC address that you see right here. It should match. Now the format's a little bit different, right? Cisco does the 4.4.4, whereas in Wireshark you use the colons. Right? It's the same. It turns out to be the same thing. So that MAC address is the same. Now if you go into the interface inside of your router 1, conft interface fast00, you can change your MAC address, pretty easy, MAC, and then you just do, let's say, AAAA dot AAAA dot AAAA. 12 dots, or 12 letters separated by 2 dots. Hit enter, and now if you end out of there and show interface fast00, you should see, if we scroll up here, you should see this. Address is all A's. Your burned in address stays the same. Burned in address is it's burned in. You can't change that. But the MAC address that you have now is all A's. So how many of you were able to change the MAC address on R1 fast00? So, changing the MAC address is actually pretty easy because is pretty awesome, because if a particular company or device is tracking you by MAC address, you just change the MAC address to something else. Say, that wasn't me. That wasn't my MAC address. I don't know what you're talking about. Now, if you're going to change, if someone was tracking and they were looking at MAC addresses, changing your MAC address to all A's would be completely stupid, because that's just a red flag that someone knows how to change their MAC address. If you were trying to hide, I would change your MAC address to, let's say, a airport MAC address, an Apple MAC address, or a Dell, or something like that. Then that way it's plausible deniability. It's like, hey, there was another Mac there, so that must have been him. So now if we look in our capture, you can see now it looks a lot better, right? This KeepLives is now all A's. The source for our CDP is all A's. So now we could easily see, okay, we know that's router 1. Not a problem. And for those of you who don't know, there are many programs within Windows and Linux. Well, Linux you don't need to program. You could just change your MAC address. But Windows, you have programs, and I think you could just easily go into the registry and change your MAC address. But there are lots of things that let you change MAC addresses inside of Windows. Okay. So now the filtering, if you want to filter, it's really easy, because if you do eth.addr ethernet.address equals and just do all A's, it's a lot easier to type. Now, it's easier to type if you're on QWERTY. If you're on Dvorak, typing A's and colons in quick succession sucks, because the colon key in Dvorak is the Z key on QWERTY. Okay, we'll clear that out. Okay, so far nothing too big of a deal. Let's go to R2. Let's bring another router into the mix. We'll conf t interface fast00. No shut that puppy. And we should start getting another MAC address in the mix. So this is R2 coming up. And kind of the same pattern. Look at that. Whoa, didn't want that. The same pattern. Notice what CDP does when you fire up an interface. So it shot out CDP, CDP, CDP. So we have that. We have that. And we have that. All right, so how many of you see in your Wireshark, as soon as you turn on the interface of router 2 fast00, you see 3 CDP frames fire up? Right? Packets don't lie. You're seeing exactly how it works. So if people, if the test for some reason, or in an interview, this is, in the test, they're going to basically just ask, okay, CDP, how often does it happen? Okay, 60 seconds. That's good, right? I highly doubt in a CCNA test or even a CCNP test, how many CDP frames are sent out when you turn up an interface? I highly doubt they're going to ask that, right? But I could see maybe this would be kind of like a real world type question in a job interview. You could add in, well, it's every 60 seconds, but when you first turn on an interface, you get 3. And then they'd be like, whoa, how'd you know that? Okay, so this MAC address, ugly, don't like it. So we're going to change router 2 side, MAC BB 4Bs dot 4Bs dot 4Bs. So all Bs. Whoop. MAC address. Malformed hex address. Okay, hold on. Show int fast00. Oh, let's try another one. Yeah, okay. B000. Okay, I took that. Okay, so B followed by all zeros. So as soon as you did that, you can see that now you're getting the KeepLives have changed instantly. CDP has updated. And life is good, right? So that should be pretty easy, changing your MAC address. Okay, so for KeepLives, we turned up one side of the interface. We saw what happens in Wireshark. We see how often it's happening. So we see that if we filter everything out, so let's filter everything out by router 1, so router 1 interface. So just click on any frame that says all A's in the source, expand out Ethernet 2, in this option down here, expand it out. And then right click under source right here. I'll underline it. So right click that guy, and we're going to make a filter for it. So right click, apply as filter, selected. So we just want to see that guy. Right? So now remember, we've got router 2 in the mix, so our packet capture is a little bit more complicated, not too much. All right, so now if you look at these KeepLives, how many seconds in between the KeepLives? 10 seconds, right? And that should make sense because if you go into router 1 and you show interface fast00, you're going to see that if you scroll to about right there, you're going to see KeepLive set 10 seconds. So we're going to change that. Interface fast00. One thing you could do is you could say no KeepLive. Stealth mode, no KeepLive. And now if you just sit, it's just not going to happen. Not going to get any KeepLive. This was one of the tricks for those of you guys who were doing CCIE version 4. You know, they would always ask you stuff like, you want the frame relay to always be up. How do you force it? Stuff like that. And this was back-to-back frame relay. You do the no KeepLive. Thank God frame relay is no longer in there. Okay, so KeepLives have stopped. You can also do KeepLive if you were crazy, KeepLive 1. And now your Wireshark will be, every second it's going to come up. Right? And let's just change it back to 10. Having KeepLives every second is kind of, we don't like that. It's bad. Right? So KeepLive every 10 is fine. Okay. All right, so we know that KeepLives happen every 10 seconds. We know how to stop them, and we know how to change the interval on those KeepLives. Any questions on KeepLives? Very simple stuff. Okay. So right now you've got your Ethernet source equals all A's. So you're basically saying everything coming from router A or from router 1's interface. I'm selecting on screen, right? Let's say you want to save this file. You want to just save these packets because this is a filter of your entire packet capture, right? So if you want to see the entire packet capture, select the filter and let's copy that just so you don't lose it. And if you clear it out, this is your entire packet capture. It's probably like 1200, 1300. You know, it's a lot of frames, right? Just a whole bunch of stuff. But if you just want to save everything pertaining to router 1, you throw in the filter, then you go up to File, right? Or actually you would stop your capture. Right, so now your capture stopped. Now you go up to File, Save As. Right? Now if you save as, you'll notice that you get, I've got two of them. You got, it just tells you, okay, what do you want for your file name? Right, what do you want for your file name? It gives you different formats you could do. There's a whole crap load of formats. You can compress it. If it's a big file capture, it's very advisable to compress it. Now, if you go to File and Export Specified Packets, It's down here kind of like in the middle there, export specified packets. Then this is a little different. Now, I kind of wish that this menu option right here, that if you went to save as, that you would get this option anyways. It's kind of weird that these aren't unified, but whatever. So you can see here that we could say all packets. Okay, so we can select all packets, but up here kind of in the upper right hand corner of that section, you can see this. So give me all the displayed packets. So all the ones that are filtered out. And then save them. Right, so that's how you save a bunch of filtered out packets. Now you may be wondering, what's this guy right here? Marked packets. Marked packets. All right, so if we cancel out, let's go back to our packet capture here. As we click through, you can click on any packet, doesn't really matter, right? If you hit Control M, that marks it. Control M, and let's see if we could mark a whole bunch. All right. You can also right-click, mark, right-click, mark. You can set a different keyboard shortcut if you want. So I've got a bunch of marked packets. Basically, you're just highlighting them. And then you go up to File, Export Specified Packets. And now this marked packets option right here is now available. It says you have 6 packets marked, and you can save those if you want. So that's pretty easy. Or just save the whole thing and carve it out later. I'll paste in the HackPad link. Okay, KeepLives is very easy. MAC addresses, we pretty much covered it. We figured out how to change the MAC addresses. It's just a MAC command, MAC AAA, or MAC B in all zeros. Nothing too crazy about that. We changed the MAC addresses for router 1 and router 2, right? So not a big deal. We found out that the MAC address change takes effect right away. You don't need to shut, no shut on that interface. Very easy stuff. So one thing we did not do, just for kicks, okay, so start your Wireshark capture again, and you can continue without saving. We don't need to save that old one. Whoop, it bombed out. So if it bombs out, just close it out, go back to GNS3, right-click on the link, start Wireshark, and it should start working right away. This is what I'm talking about. Sometimes it's a little bit unstable. Okay, looks like it began where it left off, but that's okay. It's fine. Okay, so go to router 2. Router 2. So we're going to do something fun here. We're just going to see what happens. Now if we go back to our diagram, so keep router 2 open. If we go back to this diagram, we set router 1 side to all A's. We set router 2 side to B0000. So let me pose a question to you. What would happen if I go on router 2's interface right here? Or what do you think would happen if, let's say, I go to router 2 and I set that side to all A's? Do you think this would be a good thing or a bad thing? If router 2 side has the same MAC address as router 1 side. Yeah, it might be bad. Yeah. Now, of course, in the books, they always say it's bad, but it's a lot better to see what happens in Wireshark, right? This is one of these things, okay, the professor tells you it's bad, but why is it bad? Let me try it, right? Okay, so let's go over to router 2, conf t, Mac, all A's. Oh, go into interface. MAC address all A's. Link comes up. And let's take a look at Wireshark. Let's see what happens here. Okay, well, we were getting Wireshark stuff. Now, we can't tell which side is which now because both sides have the same MAC address, right? There's nothing crazy being sent out on the wire. Everything's fine for now. But when we set IP addresses, you're going to see what fun happens, right? Right now, nothing has an IP address. It's just MAC addresses, so I think we're good. Right? If you look on R1 and R2, nothing too crazy is happening on the screen. If you had logging set up, you'd see nothing wrong with the logging. Everything's good. There's no problem here. Not yet. Okay. Now let's go to R1, conf t, go into interface fast00, and we'll do an IP address. IP 1111, and make it a /24. Right, so we just threw an IP address on that guy. So all ones /24, right? Yeah, what the heck was that? DEC MOP remote console, DNA remote console. Never seen that one before. Okay, so nothing too crazy yet. If I got hacked on that GNS3 link, that would be bad. Okay, we go to R2, and we're going to set an IP address on fast00, 1112 /24. Right? Okay, so now the fun begins. We're going to keep Wireshark up, open up router 1 side. If we show MAC address, show MAC address table, MAC address table, man, show MAC dash address table, nothing there. If we show ARP, so ARP is telling us that if we want to get to all ones, which is our address, it's all A's. Watch what happens when I try to ping 1112. I'm pinging 1112. You can see it's bombing out on me. Should bomb out. If we look at Wireshark, it's saying, okay, there's my ARP request. ARP. Who has 1.1.1.2 tell 1.1.1.1. Who has 1.1.1.2. We have all of these ARP requests. We don't have any replies. All right, so things are not working too well. If we go back to R1, show ARP, so look at that. We have got this guy right here. So I have an incomplete ARP entry for 1112, and that's because when you do a ping to an unknown ARP, it's going to cache it for a little bit. It basically means that you tried to get to 1112, you couldn't find it, and now we're just kind of sitting here. It's incomplete. Don't know how to get there. Right? So watch what happens if we do this. If we do, we stay on R1. Let's ping 1112. So it's the same command, but we're going to do a repeat of 100. So it's going to just sit there and ping, ping, ping. Of course, we already know it's not going to work. Now we go to R2. Go back into the interface, fast00. We're going to change the MAC address to B 000 000. So B followed by a whole bunch of zeros, right? Okay, cool. Thank you, Michael, for reminding me. Okay, I just changed my MAC address. Boom. And as soon as, oh geez, I shouldn't have done that. But as soon as I changed that MAC address, what happened? Let me stop this guy. There we go. If you stop your pings, don't stop your pings, but stop your Wireshark, you're going to get a frame that looks like this. It's ARP. It's a gratuitous ARP. Look at that. 1112. So you changed the MAC address on R2. R2 came up and said, hey guys, just to let everyone know, I am 1.1.1.2. That's a gratuitous ARP. When you tell everyone your own IP address, it's like a preemptive strike. So, I know people say a gratuitous ARP is bad, blah, 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 blah. Not necessarily bad. You're going to see one of them when your interface comes up with the IP address. Now, if you want to see if you're getting hacked, if you see too many gratuitous ARPs, here's what you can do. Find that packet with the gratuitous ARP, click on that guy, click down here in the info panel under address resolution protocol, expand it out, and ARP has different op codes, different codes, code 1, code 2, code 3, code 4, stuff like that. This opcode 2 is for ARP replies, and a gratuitous ARP is basically a reply to itself. So if you right-click on that opcode, you can filter everything out. Filter out all the ARP replies and gratuitous ARP. So these two, this is router 2 saying that it has 1112, and this is router 1 saying that it's got all ones. And then as soon as the gratuitous ARP went out, router 1 knows the correct MAC address, and then all your pings flew through. Right? And you saw the pings. If you go to your filter list and you type in ICMP enter, that's all your pings. Echo request, echo reply. See, this is all ones going to all twos, or 1111 going to 1112, 112 going to 111. There's a term for this. I think the guy at Wireshark calls this ping-ponging, when it goes like here, here, 1 to 2, 2 to 1, 1 to 2, 2 to 1, right? It's basically they're sending to each other. Right? Okay, so let's take a look here at what we covered. We did CDP, we did gratuitous ARP. Gratuitous ARP, all it is, opcode 2 has its own MAC address. You're saying, hey guys, you're going to get to this IP address, that's mine. And we are going to end it up, we didn't get to CDP, we'll do that later. And we will end it up with statistics, and that will be it. Okay, statistics is just a very quick overview of the packets that you have. If you go up here to statistics, it's up in the menu bar up there. Click on statistics and summary. You're going to get this option down here total number of packets, total number of packets displayed. You can see like the bytes per second, all that good stuff. All right, so that's very easy. The other thing I like to do is if you go to statistics and protocol hierarchy, it's the number 4 item down, protocol hierarchy. It's going to tell you, okay, this one was how much TCP, how much Ethernet, how much HTML, all this stuff. You see the ICMP, I had 100, quite a bit, and that's because I had a bunch of about a bunch of pings go through. Okay. So we did a little review. We did some filtering. We went over, at least we covered ARP, we covered KeepLives, and we covered some other stuff like changing your MAC addresses. We looked through how Wireshark behaves under all of that, and we saw what happens when you change the MAC address to the same on both sides. You can see that the pings did not go through.